Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. I'm really excited about our topic today. Yeah, me too. This idea that we're kind of rushing headlong into something with AI, it makes you think, doesn't it?
Absolutely. This whole race to ASI thing, I think, is actually counterproductive, to be honest. It feels like we're focusing on the wrong metrics.
Right, like, are we really thinking about the underlying principles? Or are we just trying to brute force our way to some vaguely defined intelligence?
Exactly. I was reading this paper, Why a Race to Artificial Superintelligence is Self-Defeating, and it just resonated so strongly with me. It highlights how this intense focus on just outperforming each other without really understanding how intelligence works, it's probably leading us down a dead end. I agree with that. I mean, a race implies that whoever gets there first wins, right? But what if getting there first means building something that's not actually all that intelligent, or maybe even dangerous? We need to be careful. It's like we're trying to win a marathon by just running faster and faster, without actually figuring out what kind of shoes we should be wearing or what the route even looks like. We're blindly chasing an outcome. Yeah, and we're so focused on speed and competition, we're missing the fact that the very core algorithm might be flawed. It's like trying to build a skyscraper on sand. We're assuming the foundation is solid when it's not.
And the thing that's worrying me is this current approach relies so heavily on raw processing power in these massive data sets. It's brute force, without any real fundamental understanding. Like, where are the principles of human cognition coming into play? Well, I think that's where deep learning comes in, right? It's the way we're mimicking the human brain, neural networks, massive parallel processing. It's all there, it's just about making it better with more data. It's not about doing something totally new, it's about refining what we have.
See, I'm with you on that. I think it is a critical flaw. We're basically creating these really impressive pattern-matching machines that can generate really convincing outputs, but without any real-world model that allows it to reason or generalize. It's like they don't truly understand what's going on. That's the real problem. How to represent and manipulate information in a way that allows that.
Exactly. It's like they can generate plausible sentences or recognize faces, but do they grasp the meaning of those sentences or the emotional context of those faces? Or is it just complex correlations, basically fancy statistics? There's a profound difference. Well, yes, but the complexity and nuances are improving all the time, and the amount of data we're feeding the models is massive. The Elusify project, for instance, it's an incredible example of the kind of power we have now for language analysis. It's showing us that deep learning, with the right focus, can truly understand linguistic data and build on that. But what is understanding, though? I think this is the crucial thing. You can feed it all the data in the world, but without the underlying architecture that can actually represent information and relationships between symbolic concepts, it's still just playing a very complex statistical game, right? It's still a black box. And there's the missing piece, the bit that no current machine or deep learning model can do, translate different coordinate systems. It sees an image as pixels, but not in space, and it remembers a time, but it can't use it in the right context across different representations. It can't build a solid, usable model of the world. That translation algorithm is the real gap. Right, and I keep thinking about how human children learn. They don't just learn from these massive data sets. They learn from interacting with the world, from physical experiences, from building an understanding of space and time, and developing a symbolic system to communicate and reason. It's not just pattern matching. It's much more than that. But that's where we're pushing deep learning, right? With reinforcement learning and more interactive systems, we're moving towards a place where it's not just about pattern recognition, it's about learning through experience. And I think that we can achieve AGI with current deep learning architectures. We just need a larger model and more training data.
I am not sure about that. The way the brain represents information feels inherently different. It's not just about having more layers in a neural network. We're missing the critical piece of how to build neuro-symbolic architectures that can really reason. It's like we're building a car but forgetting the engine, focusing just on how to make bigger wheels.
And it's all happening in a static frame. Deep learning, it's basically like a snapshot of the world, but we actually exist in a continuous, flowing space-time continuum. We need AI that can perceive and reason about the world as dynamic. To do that, we need a core algorithm that understands different coordinate systems and how to translate between them. That's the foundation for anything that can be called a truly intelligent system. Yes, and I think we also need to look at how the brain represents language. It's not just processing words as sequential patterns. There's an active construction of symbolic representations of meaning. The initial stages of learning language in infants show this. It's not just statistical correlations. It's a deeper symbolic mapping that is totally lacking in our deep learning models.
Well, I think you can achieve that by making neural networks larger and deeper, and training them for longer. The Alusu project is a testament to the current state of the art, showing incredible strides in understanding and processing linguistic data. I mean, with more computing power and more data, we'll see even greater progress. But is it understanding, or is it just more complex imitation? You can give it all the text it could possibly read, but without the mechanism to manipulate symbols and build semantic structures. How can you actually say it is understanding anything beyond statistical patterns? There's a qualitative difference we need to address. And that understanding isn't just about patterns and logic, it's also about space and time, the context, everything. Current AI is like an isolated brain in a vat processing inputs but not understanding the dynamic, spatiotemporal relationships that form the very fabric of reality. That's why current models are brittle and they lack adaptability. Exactly. And the race mentality, focusing on just raw performance metrics without rigorous study of the fundamental cognitive processes. It's dangerous, like we're building something potentially powerful and not even understanding its limitations. We're basically running into the dark. But aren't performance metrics essential to measure progress? How else would we know that a model has gotten better or worse? I think these are important and essential to progress in the field. They're not the only things, but they are absolutely necessary. But if the metrics are flawed, if they're not capturing the essence of intelligence, then they are pointless. We might be optimizing for the wrong things. Focusing on things like accuracy on a narrow dataset is not the same as having understanding or general intelligence. We're focusing on the wrong things again. And our metrics do not account for spatiotemporal understanding. It is the elephant in the room that is always ignored. You can train an AI to play a computer game, but that's a closed system with a defined rule set. It doesn't account for the dynamic complexity of the real world. And the fact is, no amount of gaming can overcome this fundamental lack of a core spatiotemporal model. Yeah, I think we need to take a step back and really investigate more fundamental questions about how intelligence works. Look at how the brain uses symbolic representations and context and how it builds a model of the world. That's a totally dynamic model in space and time. But don't you think deep learning provides that kind of model? We're moving towards more sophisticated architectures and training methods, and I think that it's clear deep learning is the only path towards that. I mean, the level of improvement in NLP and computer vision alone demonstrates the power of our current models. It's progress, no question, but not a path to true general intelligence. It's still fundamentally limited by its statistical approach and its lack of explicit symbolic reasoning. It's like we're refining a calculator when what we really need is to understand the principles of mathematics, and that requires symbolic representation and manipulation. Deep learning is just a fancy calculator. And a calculator that doesn't understand the space around it or that time exists and has an effect. I think what is missing is an algorithm that can translate between different coordinate representations. Until we understand how that can be achieved, we are going to be stuck in this cycle of just throwing more data and compute power at deep learning, with diminishing returns. Exactly, I was thinking we could start looking into more neuro-symbolic approaches, blending the strengths of neural networks with the symbolic power of logic and knowledge representation. Maybe that's a better way to bridge that gap between pattern matching and actual understanding. But simplicity isn't necessarily a virtue if it means sacrificing fundamental abilities. The brain isn't a simple pattern matching machine. It's a complex system that combines different kinds of representation, including symbols, logic, and sensory data. If we really want to build intelligent machines, we need to go beyond the limitations of deep learning and explore these more complex, hybrid approaches. And that complexity would be rooted in the reality of the world. It's about building a model that mirrors the world, which is dynamic, not static. It needs to be rooted in the relationships between things that exist across time and space. That's why the core algorithm needs to be able to translate between all these different forms of representation. Yes, and I think this requires a more interdisciplinary approach. We need more neuroscience involved, more cognitive science, and even more philosophy to try and understand what intelligence actually means, before we rush headlong into building something we might not be able to control. I totally agree with the collaborative and interdisciplinary approach. We all have our expertise, and it's important to merge those. I just think deep learning can solve these problems, and that it's absolutely the way forward. We need to look at the right architecture, find the bottlenecks in our system, rather than jump ship to something completely new. I think the answer is hiding in our current paradigm. But that might mean accepting some hard truths about the limitations of current approaches. We might need to move away from this singular, data-driven focus and try to understand how the brain builds explicit models and symbolic representations of the world. And that's fundamentally lacking in deep learning. It's time to consider that there are other approaches that have a strong theoretical grounding.
and that the theoretical grounding needs to include space and time and how we translate and relate those coordinates. We can't just brute force our way towards AGI. We have to understand the underlying principles. And I suspect that the principles are rooted in the structure of the universe and the way things relate to each other across space and time. It's not about better training, it's about a fundamental rethinking of the core algorithm.
So, thinking about future research, from my perspective, I'd like to see more work on how neuro-symbolic AI can incorporate spatiotemporal representations. I mean, can we design systems that learn symbolic representations grounded in real-world experiences, and that dynamically update them through interactions? And what can we learn from how infants develop their language and model of the world? I think we need to focus on improving deep learning architectures, specifically their limitations in handling symbolic reasoning. We need to look for a way to integrate symbolic representations in deep learning paradigms. I'd also like to see more research into the role of explicit reward structures and a deeper understanding of how we design our reward systems so it aligns better with the human values, and a deeper analysis of bottlenecks in our current system and ways to fix it. That's a great summary. It's clear that we have a long way to go, but I think this conversation highlights some of the important questions we need to explore. We definitely need to rethink the current race to ASI and slow down and understand what we're actually doing. Yeah, it's a fascinating field, and definitely there's room for a lot of exploration. And it's important to have all those different viewpoints and work together. Absolutely. It's a complex issue, and it needs a really collaborative effort and a real understanding of the problem space. Right. I think the more we understand these complexities and address them directly, the better chance we have of actually building something truly intelligent, rather than just another complex piece of software. Well, thanks everyone for a great discussion. That's all the time we have for today. Join us next time on Cognitive Spirals.